Welcome to this DevTV presentation on the AutoCAD.net API. This is Session 5, Dictionaries, Containers, Type Identification, and Casting. In this session, the main objective is to understand how dictionaries are used in the API to store data. This will include a discussion on XRecords. We'll also learn how to traverse other containers, such as the block table, and two other topics we'll cover are type identification and casting. In the AutoCAD drawing database, there are dictionaries. A dictionary is a type of container that only contains data or other dictionaries that contain the data. These are non-graphical objects that are derived from DBObject. Dictionaries do not contain objects that are derived from DBEntity. Each item in a dictionary will have a key that will allow you to find out if a particular item already exists in the dictionary. You use the getAt method or the item property for this. If you examine the database of a brand new drawing, you will find that a dictionary is automatically created. The name of this dictionary is the Named Objects Dictionary. It's commonly referred to as the NOD or NOD. This dictionary will contain other dictionaries. You can think of it as the root dictionary for the drawing, and it is used to store data at the database level. There is another type of dictionary that can be created. It is called an extension dictionary, and it can exist for any entity in the drawing. You use the extension dictionary to store data with that entity. This dictionary is only created by a custom program and does not exist by default. Let's use the ARXDBG example to see the dictionaries in the AutoCAD drawing database. Okay, here we are in AutoCAD. First of all, let's go ahead and run the ARX command and load arxdbg.arx. This is that sample that is included with the ARX SDK. So I've built that ARX and I'm going to load it. And then I'm going to run the snoopdb command by clicking on database info in this context menu. Shows a tree view of the AutoCAD drawing database, and here we see the block table. And in model space, go to entities in block, and look at this. There's one line in this drawing, and there's no extension dictionary. You see how the button for the extension dictionary is grayed out. So that tells me that there is not an extension dictionary on that line. In the dictionaries, you see the root dictionary. It's an ACDB dictionary. You can see that there. And it has these other dictionaries that are part of it. And this is pretty much a brand new drawing. It just has that one line. Under ACAD layout, that's a dictionary, and it has ACDB layout objects under that. So this tool is very interesting. It helps you understand the AutoCAD drawing database. But what we're trying to get to is how to add new dictionaries to the root dictionary and also to the entity, this ACDB line, so it'll have an extension dictionary. This is what we're going to do in Lab 5. So I've already loaded it, and it has a couple of commands. One is add data. It prompts me to select an entity to add the extension dictionary to. I'll select that line, and there's another command called add data to NOD, N-O-D, and I've run that command. So let's go back and look at the database. And in model space, there's this line. Notice now that it does have an extension dictionary. I'll select extension dictionary. And there's one object that command added, and it's an ACDB XRecord. If I go look at the DXF for that XRecord, I can see that it has some data added. My stock data 51.9, so it has a couple of doubles that we added with that command, and you'll see how that code worked to add this when you get through the lab. But the main thing I was just trying to explain is where the extension dictionary lives on that line. And if we go over to dictionaries now, we have a ACDB XRecord called My Data, and you can see it also has the data that was added, custom data that the code adds. So you're able to customize AutoCAD drawings by adding these entries into these collections, these dictionaries, the named object dictionary or the extension dictionary. So let's go ahead and return back to our slides now. Here are a couple of VB code snippets. The first one gets the named object dictionary, and it does this by getting the database and then using the getObject method of the transaction. Notice that you use the named object dictionary ID of the database for the object ID argument of getObject. This line of code will instantiate a variable named NOD as a DB dictionary. The second snippet shows how to create an extension dictionary by using the create extension dictionary method of the entity. One of the most common type of object added to a dictionary is the XRecord. An XRecord is a result buffer, which is a linked list of type values. A type value is a data type and value pair. An XRecord will not have a search key, and you should keep track of the order that the data is stored. In this code snippet, you can see how a result buffer is created. Notice how the constructor for the result buffer takes new type values. You can use the DXF code enumeration for the type argument for the type value constructor. The second argument is the actual value. In this first typed value, DXF code.int16 is used, and the value for this type value is 1. The data property of the XRecord is then used to incorporate the new result buffer that was created with the type values. In this series, we have discussed symbol tables, block table records, and now dictionaries. These objects are containers, and the API allows you to iterate through them. There are other objects that are enumerable as well, such as polylines, a polyface mesh, and ACES solids. When you place a block reference with attributes, you will need to iterate through the attributes of the block reference to set the values for those attributes. Here is a VB example of traversing the block table. As we have seen, you can use the working database of host application services to get the database of the active drawing. We then use the getObject method of the transaction. The argument for the object ID is the block table ID property of the database. This will get us the block table. We can then use a for each loop to get the object ID of each block table record in the block table. We would then use the block table record to add entities or take some other action. The .NET API, through the system.reflection namespace, allows you to query the metadata in a .NET module at runtime. It will also allow you to query type information for an object. The system.type class is fundamental to runtime type identification. You use the getType method of the object to get the type. In this C# example, getType and the name property are used to find out if the entity is a polyline 2D. In VB, there is also a getType function, and the equivalent in C# is the typeOf operator. You will use these functions to ensure your code is working on the right type of entity. The .NET API also allows you to cast an object from one type to another. This is necessary when iterating objects in a collection that has multiple types and you only want to work with a certain type in that collection. For example, let's say the code is iterating through the model space block table record and you want to do something only with the block references. The code would test to see if the type of entity is a block reference, and if it is, it would cast that entity to a block reference. In Visual Basic, casting is done using the ctype function. Notice that this function takes an object for the first argument and a type for the second argument. In C# you use the type in parentheses to cast the entity to the object on the left side of the equal sign. You can also use the as operator and then test to make sure the object is not null. The is operator can also be helpful to test the type of the object. Now let's go ahead and use the API in Lab 5 to access dictionaries. Here's our Lab 5 Word document. This lab is going to focus on an extension dictionary, that can belong to entities, and also the named object dictionary, which is a database level dictionary. So that would be for data that you want to have available in this drawing, like on a global scope. We'll use a couple of commands that are already existing, and you can see the code below in this document that you could add to your own project, but you don't have to recreate this code that we've already covered that's creating the command like command method. But one of the commands is add data, and the other command that we work on is called add data to node. So there's about 25 steps in the first command and another 10 or so in the next. And we'll go through these lab steps. And I'm going to use Visual Studio in the project that's already provided, so I'm not going to be copying and pasting this code. If you're going to copy and paste this code into your own project, just be sure to put it in the right place so that the command will work properly. Here's Visual Studio, and this is the Lab 5 2008 project. There's the command called add data. We're going to work on add data. This is where the lab starts. There's also some code that's already existing in here that I don't have to type in, and it's just getting an entity, and we've covered that in previous labs. And it also creates the transaction that we've covered. So in step 1, we want to declare an entity variable so we can use the entity that the user has selected. So let's type in dim int as entity. That was going to equal the trans. We're going to use getObject, and the getEntity result will have the object ID that we can use. This is the object ID of the entity, and we're going to open that for read. So we'll have an entity and open it for read so we can look and see if it has an extension dictionary that we're going to do here in step 2. If int extension dictionary is null, then we're going to have to recreate the extension dictionary because it doesn't exist by default. Let's put the end if after step 4, where we're going to create the extension dictionary. So in step 3, we need to upgrade the open status of the entity, and we can just do that by calling upgrade open, and that will change it from open to read to open to write. And then we just need to call the create extension dictionary method to get that dictionary created. In step 5, we need a variable as a DB dictionary. Extension dict as DB dictionary. We'll use a transaction getObject, and then the extension dictionary property of that entity will give us the object ID for it. Open it for read. Now in step 6, we want to see if the extension dictionary contains an entry called my data. And we can use the contains property, and it'll take a string. And we're going to add this data later in the code, but right now let's just see if it already contains it. And we're going to use an if then else, and we need to put the else statement after 12 and end up after step 25. There's going to be two different situations. The extension dictionary is already going to contain the entry for my data, or it's not. And here we're saying it already contains it, so all we have to do is tell the user that it already exists. But let's get the data from the extension dictionary using the getAt method. So the first thing we need to do is get an object ID of the data. It's going to be an XRecord, but let's just get an object ID of that entry. Call it entry ID as object ID. value can be returned using the getAt method of the extension dictionary. So that'll give us the object ID of that entry. Now let's just present some information to the user about the data. First of all, let's just tell the user that the data already exists. And just say something like this: entity already has data. Now let's get the XRecord from the extension dictionary. So first of all, I'm going to declare an XRecord variable. And let's open that XRecord for read. The entry ID is the the object ID of that my data that we got in step 7. Let's use a for each loop and go through that data. The data is going to be a type value. We'll just call the variable value as type value. So we'll go through all the data entries in my XRecord data. Let's move the next statement below step 12. So for each value, each type value, we'll print out the type code. And this dot is just going to make it cleaner looking on the command line. And then the value, the actual value of the type value. So this is actually step 12. Okay, so this will just print out the values in the XRecord on the command line, and this will occur after the extension dictionary already exists and the XRecord has already been added to the extension dictionary. But the first time we run the command, our else statement is going to get run because the extension dictionary will not exist in our tests, so it won't already contain the entry my data, and so we need to add that. So let's call the upgrade open method on the extension dictionary, and then we can add data to that. So let's create a new XRecord. And then we need to create a result buffer, and then we'll add that to the XRecord. And we'll also create the new type values in the constructor of the result buffer to actually add the data to the result buffer that we'll add to the XRecord later. So let's just call this result buffer data. It's a new result buffer. And the constructor for the result buffer takes type values. And the type value takes a type code as integer and a value as object. So we can use the DXF code enumeration, and we'll use int 16 and use a value of 1. So that'll be the first value for the result buffer. And let's add a couple of more entries. Actually, I think I can just copy and paste this code to add this data easy enough. So let's just go ahead and do that. So the result buffer is going to contain an integer, some text, 3 reals. And then all we have to do is add the result buffer to our XRecord. And we do that using the data property of the XRecord. And that'll equal that resbuff. And in step 17, we need to add an entry to the extension dictionary. We use the setAt method. Extension dictionary, setAt. Use my data as the identifier. And then we just add the XRecord. Let's tell the transaction about the XRecord. We use add newly created object. It's my XRecord. Now that we have our extension dictionary created, let's go ahead and add those values to our palette that we created in Lab 4. So let's make sure that the palette command was run and that palette exists. So I'll use an if statement. Make sure that the palette is not nothing. Let's put the end if after step 25. Now in step 20, let's go ahead and put some values in the tree node in the palette. We'll use a for and each node as forms.treeNode in me.myPalette treeview1 nodes we need to put the next statement after step 25. So in step 21, we need to use an if-then statement to see if the tag of the node is the object ID from the entity. So we'll use an if statement. Node tag and we need to put the end if above the next statement. We have the right entity and the right tree node. Let's add the data. So we need a forms.tree node. Call it child node. Node, nodes, and we'll add, and use a string called extension dictionary. And then let's add the data to that node. For each value as type value in the data of the XRecord. Need to put the next below step 24. Now in step 24, we want to add the value to the child node. So add a node, and the value is the text will be the value to string. So that'll put the values of the type value into the node, and you'll see that when we run this code. And then let's exit the for loop so we can break out of the loop in step 25. I'll just type in exit for. Okay, the lab's not complete yet, but we can go ahead and try running this part of the lab, this command called add data, and then we'll come back and do add data to node later. I'll just hit F5 and start debugging. Okay, AutoCAD has started up. I'm going to run the netload command, and let's make sure we load the right DLL. That's Lab 5 2008 DLL. I'll open that. I'll run the palette command, and the palette appears, and I'm going to run that add DB events to add the database events. I'll run the line command, and the line is added to the drawing, and it's added to our palette. This is the command that we added called add data. So let's get the entity. We'll select this line, and the DB dictionary was added, and let's see if our data was added. So we get the extension dictionary and the value that we added. So let's draw another line, and I'll go back to Visual Studio. Let's put a breakpoint on the line here and step through the code when we add the new data, and go back over and run add data. Select this new line, and the breakpoint is hit, and you can see that the values are being added. I'm just going to hit F5 to continue, and then you can see that in this line the new data was added. So we get a new extension dictionary, and the data is added to that. So let's go back over to our project and work on creating the named object dictionary in the second part of the lab. I'll go to debug and stop debugging. The next lab steps are down in add data to NOD. This is step 26. So we're going to add our data to the named objects dictionary, and we'll use the transaction and the object ID argument of the current database. It's the named objects dictionary ID. So we use the trans action, get object. We just use the editor, and then document database, and the named objects dictionary ID for the object ID argument of get object, and let's open that for read. In step 27, we check to see if the entry we are going to add to the dictionary is already there. So we'll use that contains property of the dictionary in an if-else if statement. This is similar to what we did above with the extension dictionary, the code's identical. It's just the dictionary exists at a different place. This is the named object dictionary at the database level. So if our named object dictionary contains my data, then we'll do something, and then we need an else statement as well. So we're going to take two different courses of actions. We'll either just get the data or we'll create it. So we put the else after 33 and the indif after 39. Now we're in step 28. So let's get that object ID of the entry in the named object dictionary. So we know that it has an entry called my data because we tested that in step 27. So we can use the getAt method of the dictionary, and we can just use that string to do that, to identify which object ID we want. And in step 29, we can just tell the user that the data already exists. We can just say something like, the NOD already has our data. In step 30, let's get an XRecord variable created. In step 31, we'll go ahead and instantiate the XRecord variable. So my XRecord will use the entry ID, that object ID that we got earlier, and then we'll open this for read. 32, we print the values of the XRecord on the command line. We'll use a for each statement, and then we need to use the name and the type value data property of the XRecord. Okay, in step 33, let's go ahead and use the write message of the editor to print the values of the XRecord. Use the type code first. Let's just add a dot here for readability. And we want the value to string. Okay, so that's the case where the XRecord already exists in the named object dictionary. In the case that it doesn't already exist, we need to add it. Let's use upgrade open on the named object dictionary because we opened it for read. Let's declare a new XRecord variable. We need to create a new res buff with our data that we're going to add. Call it data. So new result buffer, and it takes a new type value. We want to use this data is int 16, so we use the DXF code value of 1. And like I did earlier, I'm just going to copy and paste this, save some time. And that will complete our result buffer. So it has text and these reals, these numbers, and an integer. It's just an example of adding some data. In your own code, I'm sure you'll have more, something that is more meaningful. This is just to show you how to add data. Alright, so I think that's okay. Then we add our result buffer to the XRecord. In step 37, we just need to set the data for the XRecord to that result buffer using the data property. So then let's add the XRecord to the extension dictionary. We'll use the setAt method. So we use an NOD, setAt, call it my data, and my XRecord. We add the XRecord. Use the transaction, the add newly created object, and add the XRecord. And that's the end of the lab. So we made it through step 39. I'll go ahead and build this. The build was successful. I'll go ahead and let's debug. Here in AutoCAD, I'll type in netload, load our DLL. Let's run palette. The palette gets created. Let's add the events. Let me draw a line. And the new command that we finished was add data to node. And you can see that an XRecord was created. We can load the ARXDBG example, and to see that entry that we created in the named object dictionary. So let's go to database info and dictionaries, and we see my data is created, and the code here has added these settings is a DXF. So if we run add data again, the values are printed on the command line, and that command finished earlier, add data, adds data to the line, and it's an extension dictionary. And if we go over to ARXDBG database info, in the block table in model space, we go to entities. There's that line there. It has an extension dictionary called my data, and there's the values. So the lab is working fine. So hopefully you get a good idea how to go through the lab steps. And good luck when you're working on XRecords and dictionaries and extension dictionaries and the named object dictionary. Thank you for watching this DevTV presentation, and good luck when you go through the steps in Lab 5. We'll continue this AutoCAD.net API training in Session 6, where we'll show how to use the AutoCAD.net API to work with a point monitor. This is a powerful API which will allow you to monitor user input.